Today we have a problem from the AMC10A of 2022 in which we're going to explain problem 20. We are given that a 4-term sequence is formed by adding each term of a 4-term arithmetic sequence of positive integers to the corresponding term of a 4-term geometric sequence of positive integers. The first 3 terms of the resulting 4-term sequence are 57, 60, and 91. What is the 4th term of this sequence? So we have an arithmetic sequence here where it's just 4 terms. So A plus D, A plus 2D, and A plus 3D. Now, same here. We have a geometric sequence, which is B, BR, BR squared, and BR cubed. Now, it gives us that each corresponding term, added up, we have 3 of those sums. We want to find out what the 4th one is. So, the first equation, A plus B is 57. The second one is where A plus D plus BR is equal to 60. The third one is where A plus 2D plus BR squared is equal to 91. And we want to find what A plus 3D plus BR cubed. Now, the first step in solving this is, we have to subtract. So, equation 2 minus equation 1. This is just going to be equal to A plus D plus BR. That is equation 2 minus A plus B, which is equal to 60 minus 57, or 3. Now we can cross out some terms. So D plus BR minus B is 3. Factor out the B. D plus B times R minus 1 is 3. So we have our 4th equation here. And now we do the same to get a 5th one. So we do equation 3 minus equation 2. That is going to be equal to A plus 2D plus BR squared minus A plus D plus BR. This is just equal to 31. So 31. Now, we can just cross out some terms here. The A is crossed out. There's one D. So D plus, BR squared minus BR is also equal to 31. Factor out the BR. So D plus BR times R minus 1 is 31. And we have our 5th equation. Now, we use the same strategy on how we found these to use it on these 2 equations. So what I'm talking about is equation 5. Subtract equation 4 from equation 5. So this is just really D plus BR times, here I'll write it in brackets, so this 1 minus D plus B times R minus 1 is equal to 31 minus 3, or 28. The D's cross out. What you're left with, these 2 terms both have a factor of R minus 1, so we can take that out. So R minus 1 times, that's just going to be BR minus B, still equal to 28. We can now take out a B term here, so r minus 1 times b times r minus 1 is equal to 28. We now see that this can be further implemented because there's two r minus 1s, so this is just r minus 1 squared times b is equal to 28. So we can just, since we are already given that all numbers are integers, we can just find out all the possible ways 28 can be multiplied and plug it in and get our answer. Now, we have to break up 28. There are only 3 ways it can be broken up. Well, there are only 3 ways since they have to be all integers. So 28 is equal to, one possibility is 1 in 28. The second possibility is 2 in 14. And the third possibility is 4 and 7. Right there. Well, we already see a problem with this term or possibility. We know that that is incorrect because there has to be a square here. Both of these terms are not a square. Now, 1 and 28 seems intriguing. So we try and plug it in. 1 is a square, so r minus 1 squared is 1. R is equal to 2. And so, according to that logic, b is 28. When you plug it into the first equation, you get that a is 29. So let's use this equation. So we a is now 29. 29 plus d, that's our unknown, plus br, 28 times 2, 56 is equal to 60. So d is equal to, I believe, negative 25. So now we have something, but let's just try with the arithmetic sequence. So the first term is a 29. Second term, 29 minus 25 is 4. Third term, 29 minus 50, that's like negative 21. So we are given that they are positive. So this certainly isn't a solution. So meaning that this is probably correct. With one term remaining, this is most likely the correct one. It most likely has to be. So we see that 4 is a square. R minus 1 squared is equal to 4. So therefore, R is equal to 3. And so therefore, now we know B is 7. So we plug this value in to, first we have to find out what A is. Pretty simple. We know that B is 7, so A has to be something plus 7 is 57. So A is 50. Now we have our 3 values, 50, 3, and 7, or A, B, and R. So we plug it in here to find out D and see if it's correct. So A is now 50 plus D, that's still our unknown, plus B times R, 7 times 3, 21, is equal to 60. So after some adding and subtracting, you get that D is equal to negative 11. Now we try it on the arithmetic sequence. On the first term, 50 is still 50. On the second term, 50 minus 11 is 39. On the third term, 50 minus 22 is now 28. And in our final term, 50 minus 33 is 17. So we know that that checks out. We just have to find the final value of BR cubed. That's pretty easy. First value is B, so 7 7 times r, or 3, so 21. So b times r, 7 times 3 squared, or 9. 7 times 9 is 63. Since they're all being multiplied by 3, br cubed is 63 times 3, or 189. So therefore, we have our fourth value numbers, like the value numbers in the fourth term. So we just add them to get our answer. So 17 plus 189 is equal to 206, which is indeed our answer.